Hello there, my name is Jacques Troussard, and I'd like to welcome you to this third game programming screencast for Computer Science 440. In this video, I will be walking you through my code, explaining in greater detail some interesting features, and finally I'll be demonstrating the game for you. For this assignment, we were instructed to build a Space Invaders clone. So, enemies spawn randomly at one end of the screen and advance towards the player, and the player, on the opposite side of the screen, tries to intercept them with projectiles. The game goes on until the player loses all their lives, or they reach the designated winning score. As always, I'll be starting off by looking at the project structure, but in this video, instead of bouncing back and forth from the main to their supporting files, I'm simply going to inspect each file one at a time. In an effort to keep the video at an appropriate length, I'll also be skipping over header files and framework type sections of the code. Alright, well now that the housekeeping is done, let's begin. Okay, great. So let's start with the bullet class here. So this is obviously the bullet or the projectile class. It's what the player is going to be using or firing towards the enemies to intercept the enemies. So let's start here. Our includes are pretty basic. We have the input-output stream, some allegros, and then we're including the header file as well. Our run-of-the-mill constructor here, which is going to take note of the X and Y position of the bullet, which is pretty important. The speed, which is set to 3 here. Its status. So this pretty much is explaining to the supporting functions this bullet has been fired or it does not exist. And then the angle, which is another kind of the part of the more complicated part of this class. And then just loading up the image for the bullet class. Just random, or your run-of-the-mill deconstructor here. So these images are allegro pointer variables, so they have to be destroyed when you leave the function call. These are just your pretty regular setters and getters. I'm not going to go over them. It's just grabbing whatever fields the class has and returning the appropriate value. Let's see. This I've added here a flip. I wanted to see if this works instead of like feeding the boolean directly. I just have this flip status. So if you're true, you turn to false. If you're the opposite, so if you're false, you go to true. I don't know if this really helped me at all. I just thought I'd give it a try this way. Alright, so here are the class methods. Drawing on screen, this is pretty standard for our Allegro game so far. Just draw this thing where I want it. The image of itself. Then we're going to feed in kind of like the positions, like, hey, where I want you to put this thing. Because it's a rotated bitmap, we have to tell the program which point we want to rotate it on. So that's why we have these two values here, so that we're rotating it from the center and not some weird position. Because if you don't get this right, then the entire image starts to swing around instead of, well, it appears to start swinging out of place instead of just rotating on its a center point. If you're not on the center point, then it looks like its X and Y positions is drastically changing. And then here we got our actual position in which to put it, the angle in which to rotate it at, and this is a flag which we don't use. Launching the bullet, just firing it in. We have these two inputs. We need to grab some information from the player, and then this is a variable that sits in main. It's called incoming angle. So the angling position of the player is its value needs to be separated into a separate variable when we try to determine in which angle the bullet is being fired. And that's why we have to put this in. Instead of just grabbing it from the player, we could just go, oh, player, grab that angle variable, because we'll have a head that's turning, and that angle can just simply be grabbed from player. But if you do it that way, what ends up happening is it's like a pass-by reference situation. So the bullet starts to rotate with the head after you've already fired it. So you have like some crazy matrix thing going on. Right, so anyways, it's pretty easy. It's just saying, hey, if this bullet is not in play, go ahead and turn it on. So we're going to set our X and Y, give you your incoming angle, and then set it to true, which is kind of like firing it. Then it's going to go down to the next frame that gets processed. It's going to be part of this group. So it's no longer not in status, it's in status now. So it's going to have this function called on it. Okay, so we're going to update your position by this coefficient here, which is the speed variable times its cosine of the angle in which it left the player. So I probably should name this a different kind of angle, like fired angle or something like that. But again, I think I mentioned it in the previous video. Microsoft Visual Studio, they might have a refactoring kind of function built in this IDE, but I haven't been able to find it. And from what I gather, it looks like you got to install some plugins, and they might not be official. I didn't want to mess around with it. So when I don't think far enough ahead, I kind of have to stick with some of these bad names sometimes, especially if the variable gets used all over the place. Anyways, it worked out in the end. So, and then here are the collisions. So this is pretty much what makes the bullet work for the player. It's going to need to know what kind of enemies are on the screen, so we're going to give it the array of enemies. It needs the array control, so this is limiting the for loop so that we don't have any access errors within the array. And then the player gets put in for incrementing their score. So the score and the level are tied in with this player class, and we'll get to that very soon. So this is pretty much just taken from the lab. There was some small changes. I'm trying to remember where I had the changes. Actually, no, this pretty much stayed all the same. So it just flips. We get the array. We check for the enemy's existence, which is this get status. If the enemy exists, then we're going to check for collision. So is our X position in your bound box, essentially? Is our Y position in your bounding box area? Within this if suite, so if we detect any of these, or if we detect all of them, I'm sorry, then we know a collision has happened. We're gonna turn the bullet off, so the bullet now ceases to exist. The enemy here, so I gave the enemy the same kind of flip status, so I'm not feeding any information in there. I don't know, it seems like this could be dangerous. So this next program, I'm definitely going to just use a regular setter where I'm telling it what boolean to use. But anyway, so if it's been hit, it's obviously alive, so we're going to flip it. It gets turned off, so its status is set to false. The player gets a score, so we're calling this method here increment score. And let's see. Oh, this is just some debugging here. I like those printout statements for debugging. I mean, mostly because I feel that I haven't practiced enough with the debugger here, the native one in Microsoft Visual Studio. Okay, so that pretty much wraps up Bullet, and we'll move on to Enemy next. Okay, so here's our enemy class. Couple more includes, so it's a little bit more complicated. Here's our constructor and deconstructor. So very similar as the bullet class before. We're going to load the image, and its position information gets set up, and then its bounding box is set by the size of the bitmap itself. It's automatically false because we will randomly generate a position for it and then launch the ghost. And then this is a speed I have it set at. So, I think maybe to defend this very simple, I'm just using the width and height and not doing anything fancy with the bounding box, I should maybe go into the theme and have you take a peek at some of these bitmaps. Okay, so the theme I decided to use was play on like a Mario theme. So I'm using one of the bad flowers, that flower that stuck out of the pipe and did the chomping one, the Venus flytrap looking one, and it would shoot fireballs. So that's the thing that's going to be defending the garden, which is sitting at the floor, and then we're going to have ghosts coming down attacking Mario's garden. So that's the idea. Let me show you a couple of these here. So this is what the level looks like, and here we have the fireball. So that's the projectile, the bullet class. These are going to be growing on the floor here, kind of representing like how many lives you have. So as the ghosts come down and pass by, it'll knock down these flowers. So I kind of ran out of time, but I wanted to do to vary the ghosts, but I ran out of time. So, but it's just this one, and you can see how square these guys are. And I did a little bit of editing in GIMP to try and get them as close as possible to fit in this square, even though they're circular. So I probably invested a little too much time into the assets here. That's why I wasn't able to finish all the things I wanted. Here's some custom like title overlays that I built. So I just used a regular got a font from DaFont. It's kind of someone made a New Age Mario theme. Alpha to select, grew it out a little bit, then created a new layer, and then gave it a color yellow. So that's how I was able to get this kind of this outline of it, which I think is really cool. Makes it very easy. They say that if you do this, it doesn't matter what your background color is, this will always stick out. So anyway, so this is kind of the player. So this is the model just to look good, and this is a static kind of the body, because this doesn't move, and then the head sits here and it's going to rotate left to right. Here are the fonts. So here's kind of like the title screen, and then the winning. Oh, can't see it. Let me. No. There we go. So you can see. All right. So this kind of justifies my lazy bounding boxes. I just wanted to get that kind of through for you guys. Alright, so back to the code. Where did we leave off? Bounding boxes. Okay, setters and getters. Let's not worry ourselves too much about this. Okay, drawing the enemy. Again, pretty simple. It's just, hey, draw the thing. I'm going to give you the image, and then I'm going to give you the position. No flag. Dropping the enemy. And there's no rotation, so this is not like the projectile that needs to remember its angle and its point of rotation. This is an even easier one. Dropping, so this is deciding whether or not to launch another bad guy. So this again was given to us in a lab. Works out to be a pretty steady and fun rate. So if you start messing with this, the game starts to feel awkward. So, but we couldn't just drop it in. We had to make some changes. So we were playing left to right in the Kirby game. Mine is top to bottom here, so these pretty much had to be reversed. And then I'm looking for the boundaries as well. So let's see, how do I okay, sorry about that. What I'm trying to say here is that this X value, so along the top edge, deciding where to put that ghost has to be within the bounds of the screen minus the size of the ghost. So you don't want to be like at the very edge and then the ghost just is 60 pixels over. So we want to keep it so that we don't have like half a ghost either. We want a full ghost to appear on the screen from one end to the other. The Y bound is just to keep it on screen when it's produced, so I don't want it to be like halfway being produced on the top. I want it to be fully into the screen when it's created. And then it gets its speed from the player's level. So it has an original speed, which is kind of silly. I guess I should just set this to 0, but I made it dictated upon the level of the player. So in the main, it uses this as kind of like a multiplying factor. So whatever level you're on, it gets like +1 or +2 depending on the level you are. It speeds up the ghost. So that's the level factor. I didn't have it create more ghosts or anything like that. It just makes the ghost come down faster. Updating the position of the player, the enemy, kind of looks the same, right? So we're going to need to, depending on what happens or where the enemy is, we might have to do something with the player, which has the score and the lives, so that's one. And then this limit here is pretty much telling us like when the ghost has reached the very bottom of the screen. And I ran out of time for this, but I wanted to make a little like bump or squish noise when it reached the bottom. So I got it working, but the problem was this: once they reached the bottom, the frames, it was like recording multiple frames. So it's not just it happens once. The loop is going through so many times. It was playing the sound like 5 times before this had a chance to turn off. Anyway, so it's just, if you're alive, we're updating your speed. Continue falling down. They only fall in the Y direction, so that's the only thing that needs to be updated. And if they have reached, if their Y is larger, because as we go down, the Y value is growing. If their Y is larger than the limit that I'm telling them, because the board is going to have like we have the ground, and then there's a black area below that, which I'm using for the scoreboard. So it's not like the ghost has to go all the way down. I just wanted to make it seem that once they hit the red part, let me pull that up real quick. Bear with me. Take a look at that. Yeah, so once the ghost comes and hits the brick part, I want it to register, -1 life. I don't want it to have to go all the way down. So I had to make like a custom, there's a custom amount for this, which is set up as a constant in main. And we'll go over that later. Yep, so this pretty much takes care of the enemy class. Moving on, next one will be our player. Okay, so here we are in the player class. Fewer includes, but pretty much all the run-of-the-mill, hey, I need to work with Allegro and then images. The Constructor is a little bit more complicated, only because as I showed you before, the player is made of a couple of pieces. So there's the plant head, which this is the rotating bit. And then these are the flowers, which are going to represent your lives. And then I was going to use a dead flower thing. Again, ran out of time. This was not required of us. I wanted to kind of be a little bit more creative. So what happens is that the flower signifies your life. As you lose lives, that's the change in your environment. So the flowers just go away. I had to hard code this. This is the position of the head, the plant head. It was kind of a pain, and I'm sure there's a nice way to do it, but when the head started pivoting, it was starting to look all weird, so I said, let me just force it in the position that I want without messing with any being fancy with variables or whatever. So I was just going back and forth. These really didn't matter. at the time of the player construction, they get set kind of dynamically within main. And here's our score. Starts at 0, start with 5 lives, and we'll start at level 1. Destructor, obviously. If we're going to call in these pointers, we need to knock them off when once we're done with the player. All our normal getters and setters. And then we have our incrementers and decrementers here. So we can increment the score every time we hit a ghost. Every time we let a ghost go by, we're going to decrement our life. And I was going to make those little 1-up mushrooms. Very rarely come down. Again, one of those features that just ran out. I thought it would be fun. I ran out of time. Not required, but that's what this was for. I mean, I figure, 3 lines of code, I'll just write it and, I'll use it when I get there, but it didn't happen. And then incrementing the level, which actually this didn't work. Can't remember exactly, but I needed to use a regular setter, so that's what this is for here. This really never got used. Drawing the player, again, had to fiddle with these numbers a little bit to get it right where I want it, because the pipe is part of the background, so I needed to get that flower right on top of that pipe. And then drawing the flower. So I thought this was kind of neat. I used a for loop, and it constantly looks for your lives, and it keeps printing the flowers, right? So print the flower, and the starting position is, the X, which is 30, and this floor variable gets passed in, so it knows where that brick layer is, much like in the enemy class, and this flag. And what happens is the start position just gets incremented. So it'll build, let's say we have 5 lives. It wants to build the first flower. Boom. Goes right here. Moves over 60 pixels. Builds another flower. Builds another flower. Builds another flower. And then as you start losing them, it starts to deduct them. So I thought that was kind of the programming way of doing it, instead of making some, I guess I could have made a big switch or an if-else statement. I don't know. This just seemed maybe even a little more Pythonic to do it this way. I like it. So yeah, the player class is actually pretty easy. I mean, it looks kind of thin, but the angling and everything gets a little bit more interesting in the next steps. So we'll move on to that next. Okay, great. So you've made it. The grand finale. We're at main finally. Main obviously does a lot of heavy lifting, so it's got a bunch of includes, including our supporting files. These 2 up here, pretty much just for debugging. You'll notice there's 2 here we weren't required for the sound, but I already kind of gave you a preview of what the theme was, and I've always thought the Mario theme and their kind of their whole, just call it that, their theme. It's the colors are very bright and they contrast very well, and it's so awkward when you have those kinds of colors and characters and then there be no sound, no music. It's just too weird, so I invested a little extra time into the audio part. Okay, so one main function called draw score. I think this is starting to become kind of a habitual thing. I think one main function is not bad at all, so yeah, I think this is just going to be a regular appearance in my program. So we grab the life and the score information from the player, and then we need a font to write it all in. Okay, so we start main. Here are our usual suspects here of constant variables, the screen size. This is that special garden floor variable I was talking about, so it turned out it was 630 pixels down from, or units down from the top of the screen to the very edge of the bricks. Here we're just setting the guard in the for the array of enemies and the array of fireballs. This is given to us as part of like a starter code, so the enumeration of the keys, and then they're all initialized to false. We have the frames per second, 60. Here are all the booleans I used. I kind of went a little crazy with the intro. So I have 3 while loops. I have one for kind of like the intro. You'll have the screen's going to slowly come down and make a little coin noise when it reaches it. And then Then there's another loop where we wait for the player to use a spacebar once they're done, like reading the instructions, and then the game starts. So there's 3 of them. That's why I have all these booleans here. Here's a variable used to control the position of the title as it scrolls down, and then here are 2 angle ones. So these are the interesting ones, right? This controls the head, so the flower head or the Venus flytrap head, and then this is that separation, so that when a fireball gets fired, I can copy it and it not be a reference, it's just a value copy. And then that information gets passed into the bullet on creation, and then it gets set inside that object. So it stops, it's now separate from this variable and no longer changes with it. Okay, so this was just some kind of painstaking edging things around. I thought it would be boring if you just started the game and the plant was there. I wanted it to grow. So these are a bunch of variables which kind of set the position of the player, and then before the game starts it grows out of the pipe. So I had to move the X and Y position of the scale. So I'm using that AL draw scaled bitmap. So I have to move the X's and I have to move the actual scaled size, and yeah, so it's kind of a headache, but this worked out to maybe about half an hour's worth of work. Here are our allegro types, all set to null, and they're going to get loaded further down main. These are all the same. We're just grabbing the we're initializing the different parts of the game and then checking if they worked. We return -1 if they don't. Fonts, the event queue. Here's the audio. So this I kind of looked ahead for this information. Didn't actually use all 3 sounds because I didn't get that last one to work. So I bet it would work on just 2, but I'll just leave it at 3 for now. Timer, registering our events, where we need information from the keyboard, from the frames per second, and our window naturally. Here we're loading everything in. So the background, our title, the game over title, the winning title. So the plant full is sort of like, so I heard on like Batman movies, the Batmobile, there was like a whole bunch of versions of it. So they had one for all the close-ups, so it was perfect and had all the nice details in it. And then that's what this one is here. And then they had like a functional Batmobile for like the chase scenes and stuff, so it wouldn't have to be perfect. It just needed to be able to perform well. So that would be well, that's actually the head and the body separated. But so here, because I lost some like pixelations and it looked funny, I kind of had to edit the image a little bit so it didn't look like the head was getting disconnected from the body as much. So anyways, while the game starts, I wanted to use the best picture, and then once the game is in play and we can start moving the head around, the kind of quality goes down a little bit. That's the philosophy behind this. And our sound files. Let's go. Okay, we're prepping the screen. We clear to black, we flip it, and we jump into this intro loop here. So it's just a copy of what we were given, but instead of all the other keys, we're just looking for space. This up here was debugging. Once you hit space, that's just skipping the intro, really. It's just waiting for the skip. That's kind of misleading because this is another boolean here, skip. So it'll go over, it'll fast forward the intro so we get to the instruction phase, and then we can skip this instruction phase and start the game. So here's the title that comes down. I don't think there's very much. This is just kind of boring stuff, like, hey, update the position of the title, every frame, add 1 to it. Once you hit the bottom, play the sound. I think it's, where's that? Oh, that's right here. So that's when we dig out of this while loop. That means everything is set in the right position. We jump out of everything, we flip the display one last time, and we play the little coin sound. So it goes like ding when it reaches the end. Then, oh, now we've added the instruction. Just see a little note I put for myself here. So instead of this was getting annoying, like going up and down, I kind of separated these, where I'm setting my variables at. Where am I? Hey, you see how I got lost there? I mean, I was doing that way too often. So we have an X and a Y. This is the text position. And then how much space I had in between the lines. So I was just updating these instead of having to do it every single time to get it right where I want it. So Mars Garden is under attack by Bowser. Use fireballs to deflect the ghosts. So left and right is our aiming. Our space bars to shoot and to start the game. Go ahead and good luck. And while not starting, so we're waiting for that space to start the game. So I didn't want to like just jump into the game. I didn't want to just arbitrarily pause it. I find those pauses really annoying because there's not very clear. Like maybe I should make a little button, a little light up somewhere on the screen so you know, oh, it's pause. It's not the fact that, you know, sometimes I'll forget and I think like my keyboard's not registering or whatever. So, anyways, so I wanted to put that control in. Once you hit the space bar, we're going to start the game. So no need to start any of this stuff up until now. So we create a player object, the enemies array, and then the fireball array. Here are like the game conditions. Like, hey, what level are we on? Have we won? Have we lost? That's what this is asking. This is a string of if statements here. So we end the game if game over is true. We're going to check the player score here. So we set current score to, we grab it from the player, get score. Then we just do little comparisons here. If you're equal to 5 and you're below level 2, you're at level 2 now. I had to do this kind of funny way because you got to remember that it's keep flying. The loop is flying through the 60 frames per second. And it's processing these events. Well, actually, these are being processed in the while loop, so it happens a lot. So I had to put this stop here and be like, okay, yeah. So if you're equal to 5, go ahead and you haven't been upgraded yet. Go ahead and go up a level. And I just realized probably didn't need that. I had it in switch before, and that's what was happening. It kept incrementing it. So, anyways, set the level to 2, and then 3, and then 4. So I made 25 the winning amount. And this, I had it in a function, believe it or not, and it was causing some strange error with the player object. So, anyways, I couldn't figure it out, so I just hard coded this in here. It's like, okay, so you get 25. I'm gonna take over the screen and just build the you've won. So we have the game title here, you win. I left the score information in there, flip the display, let them look at it for 5 seconds, and then end the game. So here we go, we're like actually playing the game now. So we're updating the positions of everything. So just the usual, this is all pretty formulaic here. A for loop, check all the enemies, and update their positions accordingly. This bump sound had to be passed in for if they reach the bottom. Remember, there was that limit, which is the garden floor. So if they reach the garden floor, I wanted to play this bump. Anyways, that didn't happen, so that's why this is vestigial right now. Let's see. Next one. Okay, try to drop new enemies. Right, so this is the drop enemy method. So it goes through, does that mod 500. If it lands on the right number, then go ahead and pop out another one if there's room in the array, if there's a false in there. So if they're all set to true, it won't produce any more. All 10 positions are true. Fireball position, same deal. It's pretty much just a copy of the enemy. Receives a lot less information though. And then we just check for the collisions. Once a fireball hits an enemy, we want it to go away. So that's what this for loop is for. Now, we're going to actually instantiate the firing with the space key here. So it goes and checks. So we have the fireball, kind of the for loop here. it'll go through all 10 of those positions. If we have, so this fire bullet checks if it's live or not. If there's room, then it's going to go ahead and allow you to switch a false to a true, and then fires it. So the angle, this is the kind of the important part here. It gets passed down into the fireball and gets set separately so that when player 1's angle changes, it's separate from the fireball. This is really simple. I'm embarrassed how long it took me to kind of think of it, but so this if statement is just controlling the pitch, so that once you reach the furthest left that I thought was appropriate, it stops. But until then, go ahead and move it to the left 0.05. Otherwise, there's a debugging statement, hey, your limit's been reached. And then it's just the opposite for the right side. Okay, moving down. Here is the section of the while loop where everything's getting drawn. So, set to black, put my background back. Here's the scoring kind of stuff. So, go ahead and, so, I forgot about this. So, draw score was causing problems too. So I wonder if it had something to do with passing the player in there, because this was another deal. So if I turned this on and drew the score this way, it was crashing. I was accessing some bad data from player, and again, I just didn't have the time to really look into it, and I haven't had a lot of practice with the debugger in this, and I feel like I know it's probably okay, but it's just not very intuitive. I feel like it's overly complicated for what it is, and a crash course in this for this class would be helpful, I think. Anyway, so instead of getting stuck on this, I just hard-coded it. So it's getting updated the same anyways. Cover up the score, and then on top of that, black box, update the information. Score, how many lives, or what level you're at, how many lives you got. Draw the player, and then draw the head. So this is just drawing the head, right? So this is this is like kind of the body of the flower, the head of the flower, and here are your lives. Again, uses that for loop, and then it's kind of like it goes up left to right. So as you lose them, you lose flowers, and prints that one less flower each time, 60 pixels away from the last one. And drawing the enemies, so wherever they're at, go ahead and draw them, and fireball, same deal. Flip the display so that we can see everything. Okay, and then this is, once we jump out of this while loop, this is kind of, I want the game over screen to be here. So this is not just the winning tile. So if you win, great. You'll win, you'll have 5 seconds to look at your score, then it'll go to this one saying, hey, the game is over, we're going to end. 5 more seconds to look at it. If you lose all your lives, it'll jump out of that while loop, and you'll just get the game over screen instead of the winning screen. Okay, so that more or less wraps everything up. So thank you for hanging on. And I try to make it much shorter than last time, but the next step will just be the demo, and we'll pretty much wrap everything up. Okay, so we're going to get the game started. Here we go. I'm just going to turn down the audio a little bit so I can explain what just happened, but as you can see, the title slowly came down, and then once it reached the designated position, it turned on the instructions, which is the green text. So we can, I'll just go one more time in case it happened a little too fast. There we go. Alright, so I'm going to go ahead and hit the space bar and give you a test run. And as you can see, the flowers are there on the left. So Oh, you see I'm on the next level because they're coming down. I'm going to let this guy go by. Getting a little bit of... But, oh, I don't think I'm going to make it here. Oh no, I won. There we go. Cool. So that's that second loop there, you can see. Went from winning to game over. Alright. And then I'll do... I guess I kind of showed pretty much everything there. I had some fun, so I want to do another one. So, yeah, I probably could have changed a lot of things to make it a heck of a lot more challenging. Yeah, I'll just show you it. Knock off those flowers so you see them. Oh, they're going to go by really fast. There we go. Game over. So, and also, I don't know if you can see... oh, whoops. Okay, let's do one more here. I'm sure that music's not getting annoying by now. Yeah, so you can see there's like small little pixelizations here. These are like the little... See, there was a lot of details I worked on to make it look nice, and I guess I'm getting a real experience here because developing this... especially near the end, I started having to make some choices and saying, oh, well, this detail is going to get overlooked. I wish sooner I was more willing to look over like small issues like this and maybe get some other things a little bit better, like the shooting of the fireball from the side. You see, it doesn't really come out of the plant. That would have been a little bit... I mean, that would have been challenging, and I would have liked to have fixed that, but... And then also have some time to figure out what's... You can see I get like a lot of hesitation. So I don't know if that's has to do with the code, like positioning the code in a certain areas to make it run better. I don't know. But anyways, I think this was a lot of fun, and I really appreciate you guys watching, and I will see you for the 4th programming screencast. Thank you.